Right now, as you settle into the quiet and the dark, the ground beneath you is moving at roughly 67,000 miles per hour. The entire planet you are resting on is racing through empty space at 19 miles every single second, fast enough to carry you from one coast of a continent to the other in about the time it takes to find a comfortable position and close your eyes. And the Earth itself is only the smallest layer of the motion. The Sun and every world that circles it is sweeping around the center of our galaxy at more than 500,000 miles per hour, a speed so vast that the numbers stop meaning anything at all. The galaxy is drifting through the darkness towards something larger still, pulling the Sun, pulling the Earth, pulling your bed and your body and every thought you have ever had along with it. You are never, not for a single heartbeat, truly still. And yet, as you feel the gentle, steady weight of your own body pressing down into the mattress, as the room around you sits in perfect and reassuring stillness, an old and simple question begins to surface. It is the same question that children ask the moment they understand the Earth is round. It is the same question the very first philosophers asked thousands of years before us. If the Earth is a great ball hanging in nothing, with no pillar beneath it, no rope above it, no shelf, no floor, no support of any kind, then what exactly is holding it up? Here is what will quietly shatter everything you think you know about the ground beneath your feet. Nothing is holding the Earth up. Nothing ever has. The most dependable fact of your entire life, the solid and unmoving floor of the world, the one thing that has never once let you down, is not real. The Earth is not resting on anything. The Earth is not sitting still in space, waiting. The Earth is falling. It has been falling for 4.5 billion years, without pause, without rest, without ever once landing. And tonight, in the dark, it is still falling. And so, gently, are you. This is not a frightening idea, though at first it sounds like one. By the end of our journey together, the falling will feel less like a danger and more like the softest and most ancient kind of safety there is. But to arrive at that feeling, we have to take apart almost everything we were ever taught about weight, about the ground, about up and about down, and then rebuild it, slowly and carefully, from the very beginning. If you enjoy slow, calming journeys through the strangest and most beautiful truths of our universe, the kind of deep dive that quiets the mind even as it stretches it wide open, do me a small favor and hit that like button and subscribe. It genuinely helps this channel grow, and it lets me keep making these long journeys into the dark for you. So make yourself warm and comfortable, let your breathing begin to slow, and let go just a little of the idea that the ground beneath you was ever truly still. We are about to fall, together, all the way down to the bottom of one of the oldest questions there is. Let's begin. The question is older than science. It is older than the wheel, older than writing, older than the very first city. For as long as human beings have been able to look up at the sky and down at the soil and wonder how the two fit together, we have been asking what holds the world in place. And for almost all of that time, across nearly every culture that has ever existed, the answer was the same in spirit, even when it differed in detail. The world must be resting on something. It simply had to be. The intuition is so deep, so thoroughly woven into the fabric of being alive on a planet, that for thousands of years no other answer seemed even possible. Think for a moment about what your own body already knows. Everything you have ever picked up falls the instant you let it go. Every cup, every stone, every drop of rain obeys the same iron rule. Things go down. They always go down. And when they reach the ground stops them. The ground is the thing that catches the world. So when the earliest peoples turned that everyday certainty into a picture of the whole cosmos, they reached for the only logic they had ever known. If everything rests on something, then surely the Earth must rest on something too. The only real question was what. In the old stories of the Hindu tradition, the Earth was sometimes imagined resting upon the backs of great elephants, and the elephants in turn standing upon the shell of an enormous turtle, swimming slowly through a shoreless cosmic sea. In the cosmology of ancient Egypt, the sky was the arched body of a goddess, held high above a flat and patient earth. Among the peoples of the far north, the heavens were a vast dome, and the world a wide disk ringed by an ocean no one could ever cross. These cultures had never met. They shared no language and no history with one another. And yet they arrived, again and again, at the very same shape of an answer, because they all began from the very same lived experience. A heavy thing needs holding up. The earth is the heaviest thing of all, and therefore the earth, more than anything else in existence, must need to be held. But every one of these answers carried a hidden flaw inside it, and somewhere in the quiet back of the human mind, people always sensed that the flaw was there. If the earth rests on the turtle, then what does the turtle rest on? And if the turtle rests on something beneath it, then what holds that? There is an old and possibly invented story of a thinker being confronted with exactly this difficulty, and answering with great and cheerful confidence that it was simply turtles all the way down. The story is usually told as a joke, but the joke conceals something genuinely profound. It quietly reveals that the entire way of thinking was a trap. Any answer that holds the earth up on a support only moves the question down by one level. The support needs its own support, and that one needs another beneath it, in an endless descending chain that can never reach the bottom. Not because we simply have not searched hard enough for the bottom, but because, as we will slowly come to see, there is no bottom there at all to find. The first real crack in this ancient picture appeared in a small Greek city on the coast of what is now Turkey. The city was called Miletus, and in the 6th century before the Common Era, it became home to a remarkable cluster of thinkers, who for the first time in the recorded history of our species, tried to explain the world without reaching for gods or for stories. The earliest of them was a man named Thales. Thales looked out at the world and proposed that the earth was a flat disk floating upon water, drifting like a great log on the surface of a still pond. In one sense, this was just another support. He had simply swapped the turtle for an ocean. But something important had quietly changed. Thales was no longer telling a story about a god holding up the world. He was reaching instead for a natural explanation, a thing that could in principle be examined and questioned and tested. The water was wrong, but the method was the beginning of everything that would follow. And then came the student. His name was Anaximander, and he lived in that same city of Miletus around the middle of the 6th century before the Common Era. Anaximander looked at his teacher's floating earth and asked the obvious and dangerous question. If the earth floats on water, then what holds up the water? And rather than inventing a deeper support, rather than stacking one more turtle onto the pile, he did something that almost no human being had ever before dared to do. He removed the support entirely. Anaximander proposed that the earth simply hangs unsupported in the very middle of everything, held in place by nothing at all. It does not fall, he reasoned, because there is no reason for it to fall in any one particular direction. It sits at the center of the cosmos, equally distant from everything that surrounds it, and so it has no more reason to move downward than upward, no more reason to drift to the left than to the right. Balanced perfectly by its own indifference, it simply stays where it is. Consider for a moment what this truly means. 2,600 years ago, with no telescopes, no mathematics of motion, no physics of any kind whatsoever, a single human being in a small seaside town looked directly at the deepest assumption his entire species had ever held, and quietly set it aside. He was wrong about the details. The earth is not at the center of anything, and it is not held still by symmetry, but he was right about the only thing that ultimately mattered. He understood, long before anyone else, that the earth might need nothing at all beneath it. The philosopher Karl Popper would much later call this one of the boldest and most original ideas in the whole history of human thought. It was not a small refinement of what came before, it was a complete reversal of intuition, and it arrived more than 2,000 years before the world had any way to prove it true. But ideas this strange rarely win on their first attempt. A couple of centuries later, in the city of Athens, the single most influential thinker of the entire ancient world, built a picture of the cosmos so compelling and so complete that it would go on to dominate human understanding for very nearly 2,000 years. His name was Aristotle, and he taught at a school called the Lyceum in the 4th century before the Common Era. Aristotle did not believe the earth floated freely in a balanced and indifferent nothing. He believed something far closer to plain common sense, and that was precisely why his answer lasted so very long. Aristotle taught that every kind of material in the world had a natural place, a home that it forever longed to return to. Heavy things, made of earth and water, naturally moved toward the center of the cosmos. Light things, made of air and fire, naturally rose away from it. The earth, he reasoned, was simply the great gathering of all the heavy material in existence, piled up at the center of everything, because that was exactly where heavy things belonged. It did not need a turtle, and it did not need a balanced symmetry. It rested at the center because the center was its home, the one place toward which all weight in the universe eternally flowed. This was a beautiful answer, and a deeply human one. It matched the plain evidence of the senses perfectly. Drop a stone, and it races straight toward the center of the earth, exactly as the theory had predicted. The heavens, made of a fifth and perfect element, turned in their eternal circles overhead, untouched by the heaviness of the world below. Everything had its proper place, everything made sense, and buried deep inside all that comfort was the very same old error, dressed now in far more sophisticated clothing. Aristotle had still given the universe a fixed center and a single universal down. He had still assumed, without ever quite noticing the assumption, that there was one true direction toward which all falling pointed. That single hidden idea would not be fully overturned for another 2,000 years, and the slow overturning of it is the very heart of our entire story tonight. There was, however, one piece of the great puzzle that the Greeks had already gotten gloriously right, and it only deepened the mystery rather than solving it. They had realized that the earth is not flat. By the time of Aristotle, careful observers had quietly assembled an overwhelming case that the world is in fact a sphere. They had noticed that when a ship sailed away across the sea, its hull vanished below the horizon before its mast did, exactly as you would expect if the surface of the water curved gently away. They had noticed that travelers heading south began to see new stars rise into view that had been hidden away in the north. And most convincingly of all, they had noticed that during an eclipse of the moon, the shadow that the earth cast upon its face was always, without a single exception, the rounded edge of a circle. Only a sphere casts a circular shadow from every possible angle. The evidence was patient and quiet and undeniable. The earth was a ball. And then, in one of the most elegant single acts of reasoning in all of ancient science, a scholar measured that ball without ever once leaving the ground. His name was Eratosthenes, and around the year 240 before the Common Era he served as the chief librarian of the Great Library at Alexandria. Eratosthenes had learnt that in a southern city called Syene, on one particular day each year, the noon sun shone straight down to the very bottom of a deep well, casting no shadow at all. Yet on that same day, in Alexandria far to the north, a simple vertical stick still cast a clear shadow on the ground. The only way both of these things could be true at once was if the surface of the earth curved between the two cities. By carefully measuring the small angle of that shadow, and knowing the distance between the towns, Eratosthenes calculated the entire circumference of the planet. His answer, worked out with nothing but shadows and geometry and a measured walking distance, came within just a few % of the true figure of roughly 25,000 miles around. More than 2,000 years before any human being would leave the surface of the world, one quiet man in a library had weighed it with sunlight. But notice what this triumph did to the ancient question. It made it harder, not easier. A flat earth could at least be imagined resting on something solid, on pillars, on a turtle, on an endless and supporting sea. But a ball, a vast and rounded world hanging in the open dark with sky on every side, and no clear top and no clear bottom. What on earth could possibly hold up a thing like that? The more clearly the Greeks came to see the true shape of the earth, the stranger and more impossible its stillness became. They had proven the world was a sphere. They had even measured how enormous it was. And in doing so, they had only sharpened the oldest question of all into something that pressed harder than ever against the very limits of the human imagination. And here is a detail of history that almost no one knows, a road not taken that would wait nearly 2,000 years to be travelled again. Not every Greek thinker believed the earth sat motionless at the centre of all things. There had long been a quiet thread of thought that dared to imagine a moving earth. A philosopher named Philolaus, in the 5th century before the Common Era, had suggested that the earth was not the centre at all, but moved instead around a great central fire hidden from our view. The idea was strange and not widely believed, but it planted a seed in the soil of human thought. And then, around the year 270 before the Common Era, a remarkable astronomer named Aristarchus, who came from the Greek island of Samos, proposed something genuinely extraordinary. He suggested that the sun, and not the earth, sat at the centre of everything, and that the earth and all the other planets moved around it, and that the earth also turned upon its own axis each day, which is why the heavens appear to wheel slowly overhead. He even understood that the stars must lie at almost unimaginable distances, so far away that their positions never visibly shifted as the earth travelled along its great circle. Pause on this for just a moment, because it is genuinely astonishing. Aristarchus had arrived at very nearly the correct picture of the entire solar system, the sun resting at the centre and the earth moving around it, almost 1800 years before Copernicus would propose the very same thing and finally shake the world awake with it. He was right, and almost no one listened. The idea of a moving earth simply felt too absurd, too contrary to the obvious and unshakable stillness beneath everyone's feet, too far from plain common sense to be taken seriously. If the earth were truly racing through space and spinning beneath us, people reasoned, then surely we would feel it. Surely the birds would be torn from the sky and the clouds would be left behind. The objection felt completely unanswerable at the time, and we will see much later in our journey exactly why it was wrong, and exactly why we feel nothing at all. But for now, the point is simply this. The truth had been glimpsed, clearly and correctly, by a single mind on a small Greek island more than 2,000 years ago. And then it was set aside and forgotten, and the motionless earth at the centre of all creation ruled on for almost 2,000 years more. Some truths, it seems, must be discovered not once but many times over, and the world itself must grow ready to hear them before they can finally take hold. Aristotle's universe was given its final and most magnificent mathematical form a few centuries later by an astronomer named Ptolemy, who worked in that same great library city of Alexandria around the 2nd century of the Common Era. In a sweeping and masterful work later known as the Almagest, Ptolemy placed the motionless earth at the dead centre of all of creation, and surrounded it with a series of vast, transparent, perfectly nested crystalline spheres. Each sphere carried one of the heavenly bodies. The moon rode upon the nearest of them, then the sun, then each of the wandering planets, and finally the fixed stars upon the outermost shell of all. The spheres turned, the heavens wheeled in their stately circles, and the earth sat perfectly still and perfectly supported at the very heart of it, needing nothing at all, because the entire cosmos was arranged in careful order around it. And here is the genuinely astonishing thing. It worked. Ptolemy's model could actually predict the motions of the planets across the night sky with remarkable accuracy. It guided astronomers and navigators and calendar makers for more than 1,000 years. And because it worked, and because it agreed so perfectly with the obvious and unshakable feeling that the ground beneath our feet does not move, almost no one ever thought to question its deepest foundation. The earth was the still and central anchor of all things. Everything else in the heavens moved around it. The question of what held the earth up had, it seemed, finally been answered, and answered forever. The earth was held up by the simple fact of being the centre, and the centre, by its very definition, has nowhere left to fall. The slow unravelling of all this began very quietly, in a tower in the north of Poland, in the year 1543. A careful and deeply cautious church official and astronomer named Nicholas Copernicus had spent decades of his life working out a different arrangement of the heavens, one he was so nervous to publish that the finished book is said to have reached his hands only on the very day that he died. In it, Copernicus moved the sun to the centre of everything and set the Earth itself into motion around it, just one planet among several, spinning upon its own axis and racing along its own great circular path through the sky. This was an earthquake disguised as a diagram, because the very moment the Earth begins to move, the entire foundation of the old and comfortable picture cracks straight down the middle. If the Earth is not the still and unmoving centre of the cosmos, then it is no longer held up by being that centre. It is not anchored. It is not at rest. It is a moving body, travelling endlessly through space, going somewhere. And that single change reopened the oldest question of all in a far sharper and far more frightening form than it had ever taken before. The Earth is not the floor of the universe. The Earth is in motion. So what then keeps a moving world from simply flying apart, or drifting away into the cold, or tumbling helplessly into the fire at the centre? What governs the motion of a planet that rests upon nothing and travels through nothing at all? And here we finally arrive at the quiet, devastating heart of the matter, the truth that all of these centuries of brilliant, careful, beautiful thinking had circled and circled without ever quite managing to touch. The question itself was broken. For thousands of years, the very greatest minds of every civilization on Earth had asked the same thing: what holds the Earth up? And they had hunted for the answer in turtles, in oceans, in perfect symmetry, in natural places, in nested crystalline spheres. But the question contained inside it a hidden assumption so deep that almost no one could even see that it was there, and that buried assumption was simply false. To ask what holds the Earth up is to assume that there is an up, and that there is a down, and that there is a single direction the Earth would surely fall toward if nothing reached out to hold it. It is to assume that there exists, somewhere far out there in the dark, a flaw that the Earth is forever being kept from crashing down upon. There is no such flaw. There is no such down. The Earth was never once resting on anything, and it was never being held back from anything either, because in the great dark depths of space there is simply nowhere at all for it to land. The honest answer to the question of what holds the Earth up is that nothing does, and nothing ever needs to. And the reason why, the real and the genuine reason why, is the most beautiful single idea in all of physics. We just had to wait, patiently, for one more person, sitting beneath one more tree, to begin at last to see it. The tree, as the story goes, stood in the garden of a quiet manor house in the English countryside, in a small village in the county of Lincolnshire. The house was called Woolsthorpe Manor, and in the years 1665 and 1666, it became the refuge of a young man who would change the way our species understood the entire universe. His name was Isaac Newton, and he had been sent home from his studies at Cambridge because a great plague was sweeping through England, closing the universities and emptying the towns. So he came home to the family farm, a brilliant and restless mind with nothing to do and nowhere to be. And there, in roughly 2 years of forced and fertile solitude, he laid the foundations of modern physics. Newton himself told the story, late in his long life, to a younger friend. He had been sitting in the garden, lost in thought, when he watched an apple fall from a tree to the ground. It is one of the most famous moments in all of science, and like most famous moments it has been smoothed and simplified by the centuries. The apple did not strike him on the head, it simply fell, the way apples always fall, the way everything had always fallen since the beginning of the world. But Newton did something with that ordinary falling that no one had ever quite done before. He asked a single, strange, and extraordinary question. The apple falls toward the Earth. The moon hangs in the sky overhead. What if the very same force that pulls the apple down is also, somehow, reaching all the way up to the moon? This was not an obvious thought, For 2,000 years since the days of Aristotle, everyone had believed that the heavens and the earth were two entirely separate realms, governed by two entirely separate sets of laws. Things on earth fell, things in the heavens turned in their perfect and eternal circles. The two had nothing whatsoever to do with one another. And here was a young man in a plague year, quietly proposing that the line between them did not exist at all, that the same humble force which tugged an apple from a branch was the very thing that held the moon in the sky. It was, in its way, as bold a reversal of intuition as anything Anaximander had dared 2,000 years before. But to make the idea work, Newton had to confront a deeply puzzling problem. If the same force that pulls the apple down is also pulling on the moon, then why does the moon not simply fall the way the apple does? Why does it not come crashing down out of the sky and onto the earth below? And the answer he arrived at is the single most important idea you will hear in our entire journey tonight. So let us take it very slowly, one gentle step at a time. The answer is that the moon is falling. The moon is falling toward the earth, constantly, in every single moment, exactly as the apple does. It has been falling for billions of years. The reason it never arrives, the reason it never crashes down upon us, is not that some force holds it up against the fall. It is that the moon is also moving sideways very fast at the same time. And so as it falls toward the earth, it also races past the earth. And the two motions combine into something that has no equivalent in everyday life. The moon falls toward the earth and misses. And then it falls again and misses again. And it keeps falling and keeps missing, around and around and around, forever. That endless falling that never arrives, that perpetual missing, has a name. We call it an orbit. To make this idea perfectly clear, Newton later imagined one of the most beautiful thought experiments in the history of science. Picture, he said, an impossibly tall mountain, so tall that its peak rises clear above the air into the empty space beyond. Now imagine a cannon sitting at the very top of that mountain, pointed straight out, parallel to the ground far below. Fire the cannon gently, and the cannonball arcs forward through the sky and falls back down to the earth a short distance away, exactly as a thrown stone would. Now load more powder and fire it harder. The ball flies farther before it falls, curving down to land much farther along the curve of the earth. Fire it harder still, and it travels farther yet. Now here is the moment where the everyday becomes the cosmic. Imagine firing the cannonball so fast, so impossibly fast, that as it falls toward the ground, the round surface of the earth curves away beneath it at exactly the same rate. The ball is falling. It is always falling, the whole time, pulled steadily downward toward the center of the earth. But the ground keeps dropping away beneath it just as quickly, because the earth is a sphere and its surface is always curving down and out of the way. And so the cannonball never gets any closer to the ground. It falls and falls and falls, and the ground forever falls away beneath it, and the ball sweeps all the way around the entire planet and comes back to strike the cannon from behind. That cannonball is in orbit. It is doing nothing more exotic than falling. It has simply been given enough sideways speed that its falling has become a circle. This is the strange and wonderful reality of every orbit in the universe. The moon is Newton's cannonball, fired around the earth at just the right speed, falling toward us forever and forever missing. The International Space Station, which we will return to later in our journey, is a cannonball too, full of people, falling endlessly around the world. And the earth itself, the very ground beneath your resting body tonight, is the greatest cannonball of them all. The earth is falling. It is falling toward the sun, pulled steadily inward by the sun's enormous gravity, in every single instant of every single day. And the only reason it never arrives, the only reason we do not all plunge into the fire, is that the earth is also moving sideways, racing along its path at that staggering speed of roughly 67,000 miles per hour. It falls toward the sun, and it misses. It falls again, and misses again. It has been doing this, falling and missing, for 4.5 billion years. This distinction matters enormously, because it completely dissolves the old and broken question. The Earth is not being held up against a fall. The Earth is the fall. There is no support keeping it from dropping into the Sun, because the dropping into the Sun is happening, right now, continuously, and has been happening since the world was born. The Earth is simply moving sideways fast enough that the dropping never reaches its destination. Take away that sideways motion, stop the Earth dead in its tracks in its path around the Sun, and the truth would reveal itself at once. The Earth would fall, in a straight and accelerating line, directly into the fire, arriving in roughly 2 months. The only thing standing between us and that fate is not a flaw, it is speed. Newton did far more than tell this story. He worked out the precise mathematics of it, in a body of work so monumental that it remade the world. He published it in 1687, in a book whose Latin title is usually shortened to the Principia, and in those pages he laid down a single law of universal gravitation that governed everything. Every object in the universe, he showed, attracts every other object. The apple pulls on the earth, and the earth pulls on the apple. The sun pulls on the earth, and the earth pulls back on the sun. The strength of the pull depends only on how much mass each object has, and on how far apart they are. One single equation, written by one man in the English countryside, described the falling of an apple, the orbit of the moon, the path of the planets, the return of the comets, and the tides of the sea, all at once. It was the first time in human history that the heavens and the earth had been shown to obey one and the same law. The wall between the worlds, the wall that had stood since Aristotle, simply fell. But Newton was not working entirely alone, and he stood, as he himself once gracefully admitted, on the shoulders of giants who had come before him. The most important of those giants was a man named Johannes Kepler, who in the early years of the 1600s, working in the city of Prague, had wrestled an extraordinary secret out of the heavens. Kepler had inherited a treasure of astronomical observations from a brilliant and eccentric Danish nobleman named Tycho Brahe, who had spent his life measuring the positions of the planets with greater precision than anyone before the age of the telescope. Poring over Tycho's mountains of data, Kepler made a discovery that troubled him deeply, because it broke the most sacred rule of the ancient sky. The planets do not move in perfect circles, they move in ellipses, gently stretched and flattened loops, with the sun sitting not at the center, but slightly off to one side. He published the first of his great laws of planetary motion in 1609. He could see, with perfect clarity, how the planets moved. What he could not explain was why, and the answer to that why was exactly the gravity that Newton would later supply. Kepler had found the pattern. Newton found the cause. Another giant whose shoulders Newton stood upon was the Italian Galileo Galilei, who in those same early decades of the 1600s had quietly destroyed one of Aristotle's most cherished beliefs about falling. Aristotle had taught that heavier objects fall faster than lighter ones, which seems at first like simple common sense. A stone certainly falls faster than a feather, but Galileo realized that the feather is only slowed by the air, and that if you could remove the air, all objects would fall at exactly the same rate, no matter their weight. There is a famous old story, very likely a legend, of Galileo dropping 2 different masses from the top of the Leaning Tower in the city of Pisa to prove the point. Whether or not he ever climbed that tower, he proved the idea through careful experiments rolling balls down gentle slopes. And this discovery, that all things fall at the same rate regardless of their mass, is far stranger and far more important than it first appears. It means the moon and a single feather would fall around the earth in precisely the same way. It means that gravity does not care, in the slightest, what an object is made of, or how heavy it is. It treats everything identically. Hold that thought gently in your mind, because it will return, much later, as the key that unlocks the deepest secret of all. There was one final piece that even Newton's great law left mysterious, and it was filled in more than a century after him. by a shy and immensely wealthy English scientist named Henry Cavendish, working in his private laboratory in the year 1798. Newton's law told you how gravity behaved, but it did not tell you how strong gravity actually was. Cavendish set out to measure it directly. He built an exquisitely delicate instrument, two small lead balls hanging from a thin fibre and two much larger lead balls placed nearby. The gravity of the large balls tugged, ever so faintly on the small ones, twisting the fibre by an amount almost too tiny to see. By measuring that minuscule twist, in a sealed room, watching through a telescope from outside so that even the warmth of his own body would not disturb the experiment, Cavendish measured the strength of gravity itself. And from that measurement, he was able to do something almost unbelievable. He calculated the mass of the entire Earth. He weighed the whole world, every mountain and every ocean and every hidden depth of it, using two pairs of lead balls and a thread, without ever leaving his laboratory. The answer was a number with more than 20 digits in it, a weight so vast that the mind cannot hold it. And the true power of Newton's law was not merely that it explained the things people already knew, it was that it could predict things no one had ever seen. Consider the comets. For most of human history, the sudden appearance of a comet blazing across the night sky had been taken as a fearful omen, a mysterious and unpredictable visitor arriving from somewhere beyond the world. But a friend and contemporary of Newton, an astronomer named Edmund Halley, used Newton's new law of gravity to study the path of one particular comet, and he made a daring claim. He proposed that the comet seen in his own lifetime was the very same object that had appeared decades earlier, and earlier still before that, returning again and again on a long and perfectly predictable orbit, falling toward the sun and swinging away and falling back, exactly as Newton's law demanded. He calculated that it would return once more around the end of the year 1758. Halley died in 1742, years before he could ever know whether he was right. And then, on Christmas night in the year 1758, exactly as he had foretold, the comet returned. A man had used the law of gravity to see decades into the future, to predict the return of a wanderer from the deep dark, and the universe had quietly obeyed. We call it Halley's Comet to this very day. But the most astonishing triumph of Newton's gravity was still to come, and it would happen more than a century after his death. By the 1800s, astronomers had discovered the planet Uranus and carefully tracked its slow path around the Sun. But there was a problem. Uranus did not move quite the way Newton's law said it should. Its orbit was very slightly off, wandering in a way that no one could explain. Some began to wonder whether Newton's great law might finally have failed, whether it broke down at the cold and distant edges of the solar system. But a French astronomer named Urbain Le Verrier had a far bolder idea. What if the law was perfectly correct, and the strange wandering of Uranus was caused by the gravity of another planet, an undiscovered world even farther out, tugging on Uranus from the darkness? Using nothing but Newton's law and the observed wobble of Uranus, Le Verrier calculated exactly where this hidden planet must be. He sent his prediction to an observatory in Berlin, and on the night of the 23rd of September in the year 1846, an astronomer named Johann Galia pointed his telescope at the precise spot Le Verrier had named, and there, within a single degree of the predicted position, sat a new planet, never before seen by human eyes. We call it Neptune. It had been found not by searching the sky at random, but by trusting the law of gravity so completely that the law itself could reveal an entire unseen world through its pull alone. Gravity was no longer merely an explanation for what we saw. It had become a lamp that could illuminate the invisible, and the very same law that revealed a hidden planet also explained something far closer to home, something you can watch with your own eyes at the edge of the sea. The tides. Twice each day, the oceans of the earth slowly rise and fall, the water creeping up the shore and then drawing quietly back again, in a rhythm as old as the seas themselves. For thousands of years no one truly understood why. Newton's law of gravity explained it perfectly. The moon pulls on the Earth, and because the near side of the Earth lies closer to the moon than the far side does, the moon pulls a little harder on the near ocean than on the body of the planet, and a little harder on the planet than on the far ocean. The result is that the water bulges gently outward, both toward the moon and away from it, and as the Earth turns beneath these bulges, every shore rises and falls in its turn. The tides are gravity made visible. Every time you have stood and watched the sea climb slowly up a beach, you have been watching the moon's gravity reaching across 240,000 miles of empty space to lift the ocean with an invisible hand. And that same gentle pull is doing something even stranger, on a timescale far longer than any human life. The tides do not simply rise and fall. As the Earth turns beneath the ocean's bulges, friction between the moving water and the spinning planet very slowly drains away a tiny portion of the Earth's rotation. The Earth's spin is gradually slowing, and the days are growing imperceptibly longer, by a tiny fraction of a second every century. Hundreds of millions of years ago, a day on Earth was only about 22 hours long, and the early creatures of the ancient seas lived out their lives under a faster turning sky. And as the Earth's spin slows, that lost motion is not destroyed. It is handed, through gravity, to the moon, which responds by very slowly drifting away from us, receding from the Earth by about 1.5 inches each year. The moon you see tonight hangs a little farther away than the moon our distant ancestors saw, and a little nearer than the moon our distant descendants will see. The fall, in all its forms, is forever reshaping the dance, gently and patiently, across spans of time the mind can barely hold. So by the dawn of the modern age, the picture had transformed completely. The Earth was no longer the still center of all creation, held up by the simple fact of being central. The Earth was a moving world, an enormous cannonball of rock and iron and water, falling endlessly around the sun, kept from the fire not by any support, but by the grace of its own tremendous sideways speed. The old question had not been answered. It had been dissolved. Nothing holds the Earth up, because the Earth is not sitting on anything to begin with. The Earth is forever falling toward the sun, and forever, by the simple grace of its own motion, failing to arrive. And that should have settled the matter completely, but it did not. Because Newton, for all his world-changing genius, had quietly left behind a question even deeper and stranger than the one he had answered. He could describe the falling with breathtaking and flawless precision. He could predict exactly where every planet would be 1,000 years from now. But there was one thing he could not do, one thing he openly admitted he could not do, and it haunted the edges of his great achievement like a shadow he could not quite see. Newton could tell you, to the inch, how gravity behaves. He could not tell you what gravity is. Understanding why requires dismantling everything you think you know about what a force even is. Newton had given the world a law of gravity so accurate that we still use it today to send spacecraft across the solar system with pinpoint precision. But the law described only the effect, never the cause. It said that the sun pulls on the Earth across 93 million miles of empty space, instantly, with nothing whatsoever connecting them. And this troubled Newton profoundly. How could one object reach out and tug on another object across a vast emptiness, with no rope, no rod, no contact of any kind between them? How does the sun even know the Earth is there to be pulled? This idea, that gravity acts across empty space with nothing carrying it, was called action at a distance, and many of the finest minds of Newton's age found it almost magical, almost absurd. Newton himself refused to explain it. In a famous and carefully chosen phrase, he wrote that he would frame no hypotheses about the cause of gravity. He had described how it behaved, with perfect mathematical certainty. The question of what it actually was, he left for someone else, in some far-off future, to answer, that someone else would not arrive for more than 200 years. And when he did, he would not merely add a deeper layer beneath Newton's law. He would tear up the very idea of gravity as a force at all, and replace it with something so strange, so beautiful, and so deeply counterintuitive that more than a century later we are still learning to fully believe it. His name was Albert Einstein, and the story of how he came to see the truth begins in an unlikely place. In the year 1905, Einstein was not a famous professor at a great university. He was a young man of 26, working as a clerk in a patent office in the Swiss city of Bern, reviewing applications for new inventions during his quiet days, and thinking about the deepest secrets of the universe in his spare hours. And in that single miraculous year, working alone and largely unknown, he published a series of papers that overturned physics, including the theory we now call special relativity, which revealed that space and time are not the fixed and separate things they appear to be, but are woven together into a single fabric, and that this fabric can stretch and bend depending on how fast you move through it. That alone would have secured his place in history forever. But Einstein was not finished, because special relativity had a problem hidden inside it, and the problem was Newton's gravity. Newton's gravity acted instantly across any distance, but Einstein had just shown that nothing in the universe can travel faster than light, not even information. So how could the sun's pull reach the Earth instantly, across 93 million miles, if nothing can move faster than light? The two ideas could not both be true. Something had to give. And for the next 10 years, Einstein wrestled with this contradiction, searching for a new picture of gravity that could fit inside his new picture of space and time. He would later call those years the hardest of his entire life. The breakthrough, when it finally came, arrived not as a calculation, but as a single, sudden, almost dreamlike thought. Einstein later described it as the happiest thought of his life. He was sitting in his chair at the patent office one ordinary day, when an idea rose up in his mind and would not leave. He imagined a person falling freely, falling from the roof of a house, falling without anything to hold them, and he realized something astonishing about that falling person. While they are falling, they do not feel their own weight at all. They feel nothing pulling on them. If they let go of an object in their hand, it does not drop away from them. It simply floats there beside them, falling at exactly the same rate they are. To the falling person, in that moment, gravity has completely vanished. They feel perfectly weightless, as though they are floating in empty space, as though no gravity exists in the world at all. Sit with how strange that is. We think of gravity as the thing we feel most constantly, the steady weight that presses us into our chairs and our beds every moment of our lives. And yet the one situation in which gravity is acting on you most purely, the situation of falling freely with nothing in your way, is precisely the situation in which you cannot feel it at all. The feeling of weight disappears the instant you truly give yourself over to the fall. This was the loose thread, and Einstein pulled on it until the entire old picture of the universe unraveled in his hands. The principle he drew out of that falling man is called the equivalence principle, and it is one of the most profound ideas in all of science. It says this: there is no experiment you could ever perform, sealed inside a closed room, that could tell the difference between sitting still in gravity and accelerating through empty space. Imagine you wake up in a windowless room, and you feel your normal weight pressing your feet to the floor. You might assume you are simply standing on the surface of the Earth. But you could be wrong. You could instead be inside a rocket, far out in deep space, with no gravity anywhere nearby, and that rocket could be accelerating forward, pushing the floor up into your feet exactly the way the ground does. From inside the sealed room, there is no possible way for you to tell which is true. Gravity and acceleration feel precisely, perfectly identical. And the reverse is equally true. Inside a falling elevator or a falling spacecraft, gravity seems to vanish entirely, and you float, exactly as you would in the empty depths of space. To appreciate how strange and how powerful this idea truly is, consider what it implies. If gravity and acceleration are genuinely indistinguishable, if no experiment could ever tell them apart, then perhaps they are not two different things at all. Perhaps they are, at the deepest level, the very same thing. And if falling freely makes gravity disappear, then perhaps gravity is not really a force that pulls on you in the way Newton imagined. Perhaps it is something else entirely. Something about motion itself. Something about the very shape of space and the very flow of time. This was the door, and Einstein walked through it, and on the other side he found a universe that no one had ever imagined. The picture he arrived at, after a full decade of brutal mathematical struggle, was published in 1915, and it is called the General Theory of Relativity. And its central idea, once you finally grasp it, will change forever the way you understand the ground beneath your feet. Gravity, Einstein revealed, is not a force at all. There is no invisible rope reaching across space from the sun to the earth. There is no mysterious pull. Instead, mass and energy bend and curve the fabric of space and time around themselves. The sun is so enormously massive that it creates a deep valley, a vast curving distortion in the very geometry of space and time surrounding it. And the Earth, in moving through that curved space, is not being pulled by anything. The Earth is simply following the natural path, the straightest possible path, through a region of space that has been bent into a curve. A physicist named John Wheeler once captured the whole theory in a single elegant sentence. Matter tells space and time how to curve, and curved space and time tell matter how to move. The sun curves the space around it. The Earth, moving through that curved space, follows the straightest line available to it, and because the space itself is curved, that straightest of lines bends gently around and around the sun, closing into the loop we call an orbit. The Earth is not being tugged into a circle. The Earth is going perfectly straight ahead, in the only sense of straight that the curved space allows, and the straight path itself has been wound into a circle by the shape of space near a star. This is genuinely difficult to picture, so let us reach for the most common image used to explain it, while being honest about exactly where that image falls short. Imagine a large, taut rubber sheet stretched flat, like the surface of a trampoline. Now place a heavy bowling ball in the center. The sheet sags and dips beneath it, forming a curved valley. Now roll a small marble across the sheet near the bowling ball. The marble does not travel in a straight line. It curves, following the dip in the sheet, and if you roll it at just the right speed, it will circle around and around the bowling ball, like a planet orbiting a star. The bowling ball never reaches out and pulls the marble. It simply shapes the surface that the marble rolls upon, and the marble follows that shape. This picture captures something real, but it hides two important things, and an honest journey must name them. The first is that the rubber sheet only shows space being curved, flattened down into a two-dimensional surface, when in truth it is the full four-dimensional fabric of space and time together that bends. And here is the second and far stranger point. For an object moving slowly, like you, like the Earth, almost all of the effect we call gravity comes not from the curving of space at all, but from the curving of time. Time itself runs very slightly slower close to a massive object than it does far away. This has actually been measured. Clocks at the bottom of a tall building tick measurably slower than clocks at the top, simply because they sit a little deeper in the Earth's gravity. And it is this curvature of time, more than the curvature of space, that bends your falling path toward the ground. You fall, in a very real sense, because time flows more slowly at your feet than at your head, and your natural path through the fabric of time and space tips you steadily downward. The bowling ball on the sheet cannot show you that. Nothing simple can. But it is true. There is one more way to glimpse what a straight line in curved space really means, and it lives in something you may have done yourself. Imagine two aeroplanes taking off from 2 points along the Earth's equator, some distance apart, and both flying due north, perfectly straight, never once turning their controls. At the start, their paths are parallel, but as they fly, something curious happens. They draw closer and closer together, until at last they meet at the North Pole. Neither plane ever turned, neither pilot ever steered toward the other. They each flew the straightest line they possibly could, and yet they came together, as if some force had drawn them in, simply because the surface of the Earth is curved. This is exactly what gravity does. The Earth follows the straightest line it can through the curved space near the Sun, and that straightest line bends it around into orbit, with no force, no rope, no pull required at all. The coming together is not caused by attraction, it is caused by geometry. When Einstein finished his theory, it was beautiful. But beauty is not enough in science. The theory had to make predictions that could be tested, predictions that differed from Newton's, and it had to pass those tests. And it did. There was a long-standing puzzle about the orbit of the planet Mercury, the closest planet to the Sun. Its orbit shifted, very slightly, in a way that Newton's law could not quite explain. Einstein's equations explained it perfectly, on the very first attempt. But the test that made him world famous came in 1919, 4 years after he published the theory. Einstein had predicted that the Sun's curving of space would bend the path of starlight passing close to it by a precise and measurable amount. The only way to see stars near the Sun was during a total eclipse, when the Moon blocks the Sun's blinding light. So in 1919, an English astronomer named Arthur Eddington led an expedition to a remote island called Principe, off the western coast of Africa, to photograph the stars during a total solar eclipse. When the eclipse came and the photographs were measured, the starlight had been bent by exactly the amount Einstein had predicted, and by twice the amount Newton's old physics would have allowed. The news flashed around the world. Space itself had been shown to bend. The fabric of reality was not the fixed and rigid stage everyone had always believed it to be. It curved and flowed and bent around the things within it, and Newton's 200-year reign quietly came to an end. In the years since, Einstein's strange picture of curved space and bending time has been tested again and again in ways he could scarcely have imagined, and it has passed every single test. And some of the most beautiful confirmations involve that surprising claim we touched on earlier, the claim that time itself runs more slowly the deeper you sit within gravity. This is not a metaphor, it is literally and measurably true. In the year 1959, 2 physicists at Harvard University, Robert Pound and Glenn Rebka, performed an experiment of exquisite delicacy. They measured the tiny difference in the flow of time between the bottom and the top of a tower only a few stories tall. Time at the bottom, slightly deeper in the Earth's gravity, ran measurably slower than time at the top. Over the height of a single building, the difference was almost unimaginably small. But it was there, exactly as Einstein's theory predicted. The flow of time genuinely bends with gravity, even across the height of a staircase. Then in the year 1971, 2 scientists named Joseph Hafele and Richard Keating carried out one of the most charming experiments in all of physics. They took extremely precise atomic clocks, the most accurate timekeepers ever built, and they simply flew them around the world aboard ordinary commercial airliners, first heading east, then heading west. When they returned and compared these travelling clocks to identical clocks that had remained behind on the ground, the clocks no longer agreed. They had drifted apart by a tiny fraction of a second, by an amount measured in mere billionths of a second, and yet by an amount that matched Einstein's predictions precisely. Time had flowed at different rates for the clocks in the air and the clocks on the ground, partly because of their motion, and partly because of their altitude in the Earth's gravity. The strangeness was real, and you could put it aboard an aeroplane and measure it. And here is the part that should genuinely stay with you. This is not some obscure laboratory curiosity with no bearing on your life. You depend on it. Every single day. The satellite navigation system that guides your phone and your car. The network of satellites circling far overhead that tells you exactly where you stand upon the surface of the Earth depends entirely on this bending of time. Those satellites carry atomic clocks, and because they sit high up in weaker gravity, their clocks tick faster than clocks on the ground, by about 38 millionths of a second each and every day. That sounds like nothing at all, but the whole system works by timing signals with extraordinary precision, and if that tiny difference in the flow of time were not carefully corrected for, if engineers simply ignored Einstein and treated time as the fixed and universal thing that Newton had believed it to be, then your navigation system would drift off course by several miles every single day. It would become useless within hours. Every time you follow a map to an unfamiliar place and arrive exactly where you meant to, you are quietly relying on the fact that time runs more slowly here at the bottom of the Earth's gravity than it does in the sky above. Einstein's bending of time is not a theory hidden away in textbooks. It is woven into the most ordinary technology of your daily life. The curving of space, too, has been seen with breathtaking clarity. Just as Eddington watched the sun bend the path of starlight in 1919, astronomers today routinely observe entire galaxies bending the light of even more distant galaxies behind them. The gravity of a massive cluster of galaxies curves the space around it so strongly that the light of objects far beyond is warped and magnified and smeared into great glowing arcs, as though we were peering at the distant universe through a vast and invisible lens made of nothing but curved space itself. We call this gravitational lensing, and it has become one of the most powerful tools in all of astronomy, a direct and visible map of how mass bends the very fabric of reality. And at the very extreme of this bending lie the strangest objects in the entire universe, the places where Einstein's curvature reaches its ultimate and most absolute form. When a great mass is squeezed into a small enough space, it curves the surrounding space and time so severely that nothing, not even light itself, the fastest thing there is, can ever travel fast enough to escape. The straight paths through space all bend inexorably inward, and there is simply no path remaining that leads back out. We call these objects black holes, and they are not holes in any ordinary sense at all. They are regions where the falling has become complete and absolute, where space curves so steeply that every possible road leads only deeper in. For a long time they were merely a prediction lurking inside Einstein's equations, almost too strange to be believed, but we now know with certainty that they are real. We have felt the ripples of black holes colliding far across the universe, as we will soon see, and we have even in recent years captured direct images of the glowing rings of superheated matter swirling around them, photographs of the very edge of a region from which nothing can ever return. They are the proof, written across the cosmos in its most dramatic possible form, that gravity is the bending of space and time, and that this bending can grow so extreme that it swallows even light. So now, at last, we can give a far deeper answer to the question we began with. The Earth is not being held up, and it is not being pulled down. There is no force of gravity reaching out from the sun to tug the Earth along. Instead, the sun has shaped the space and the time all around itself into a vast and gentle valley, and the Earth, moving forward through that valley, simply follows the floor of it, going straight ahead in the only way that straight ahead can mean in a curved world. The Earth is not falling because something pulls it. The Earth is falling because, in the curved space near a star, falling is simply what a straight line has quietly become. And this brings us to a question that, once you truly understand it, may quietly unsettle you more than anything we have said so far. If the Earth is in free fall around the sun, falling endlessly and feeling no weight, and if free fall is the state in which gravity vanishes and everything floats, then here is the question that should be pressing gently against your mind as you lie there in the dark. Why do you feel heavy? If everything is falling, why are you not floating? Why can you feel the steady, unmistakable weight of your own body sinking into the bed beneath you, right now, this very moment? The answer is as simple as it is strange, and it overturns the last comfortable assumption you have left. You feel heavy because you are not, in fact, falling. The Earth is falling. You are not. Something is in the way. The ground is in the way. And that single fact, that the ground is stopping you from falling, is the entire and complete explanation for everything you have ever called weight. Let us take this very slowly, because it runs against a lifetime of intuition. You have always believed that the feeling of weight is the feeling of gravity pulling you downward. It feels exactly like that. It feels as though something is tugging your body down toward the center of the Earth, and you call that tug your weight. But that is not what you are feeling at all. Gravity, as we have now seen, does not actually pull you in the way you imagine. What you are truly feeling, in every moment, is not the earth pulling you down, it is the ground pushing you up. Consider what is really happening beneath you right now. Gravity, which is to say the curvature of space and time around the earth, is gently trying to send your body along its natural falling path, straight down toward the center of the world. If nothing were in the way, you would follow that path. You would fall. But the bed is in the way, and beneath the bed, the floor is in the way, and beneath the floor, the solid ground of the earth is in the way. The atoms of the mattress press up against the atoms of your body and refuse to let them pass. They push back, steadily and constantly, with exactly enough force to stop you from following your falling path. That upward push, that constant resistance of the ground refusing to let you fall, is the only thing you have ever felt. It is the entire sensation of weight. You are not feeling yourself being pulled down, you are feeling yourself being stopped. This is why the falling man in Einstein's happiest thought felt nothing at all. The instant he began to fall freely, with nothing in his way, nothing pushing back against him, the sensation of weight vanished completely. There was no ground to stop him, and so there was nothing to feel. He was finally following his natural path through curved space, unobstructed, and a body following its natural path feels perfectly weightless. The weight you feel is not the presence of gravity, it is the presence of the floor. This distinction matters enormously, because once you grasp it, the whole world reorganizes itself around you. Every object that has ever rested on a surface, every person sitting in a chair, every book on a shelf, every stone on the ground, is not peacefully at rest. It is being actively and continuously prevented from falling. The chair is shoving up into the sitting person every second. The shelf is shoving up into the book. The ground is shoving up into the stone. All of it, everywhere all the time. The stillness you see all around you is not stillness at all. It is a ceaseless, silent struggle, in which the solid matter of the world holds back the endless falling that gravity is forever trying to begin. There is a way of seeing this that turns the entire everyday world inside out, and once you have truly seen it, you can never quite unsee it again. We naturally think of the falling object as the one that is being acted upon, pushed and pulled by the force of gravity, while the person standing firmly on the ground is simply at rest, doing nothing, going nowhere. But Einstein's picture reveals the exact opposite to be the truth. The freely falling object is the one that is doing nothing at all. It is simply following its natural path through curved space and time, coasting, unforced, exactly as a ball drifts through empty space when nothing touches it. It is the standing person, the one who feels so solid and so still, who is actually being forced. The ground is constantly pushing up against the soles of their feet, shoving them, accelerating them, knocking them off the natural falling path that they would otherwise follow. The person standing motionless on the earth is, in the deepest sense, the one being pushed around, and the falling person is the one who has finally been left in peace. This is genuinely difficult to accept, because it overturns the most basic feeling we have about the world. Right now, lying in your bed, you feel perfectly motionless, and you feel that gravity is gently pulling you down into the mattress. But in Einstein's universe, the truth is very nearly the reverse. You are not being pulled down. You are being pushed up. The bed and the floor and the whole solid earth beneath it are pressing upward against your body, holding you away from the natural path you would otherwise take, the path of free fall. If the earth were not there to push you, you would not feel yourself falling. You would feel nothing at all, weightless and serene, following the gentle curve of space exactly as you were always meant to. Everything you feel as weight is the sensation of being held back from that fall, of being constantly shoved off your natural course by the stubborn solidity of the ground. This is why falling, real and true free fall, feels so strange and so unsettling to us, and why our stomachs lurch when an elevator suddenly drops, or a plane abruptly descends. We have spent our entire lives being pushed, in every single moment by the ground beneath us, so relentlessly and so constantly that we came to mistake the pushing for stillness and the pushing for safety. And when the ground suddenly stops pushing, when we are at last allowed to fall freely along our true and natural path, it feels not like peace but like alarm, because we have never in our lives known anything but the push. The most natural state in the whole universe, the state of free fall that nearly everything quietly occupies, is the one single state that feels deeply wrong to a creature raised entirely on the surface of a world. So consider, very gently, what is truly happening to you tonight in Einstein's terms. You are not at rest. You are being accelerated, ceaselessly, upward, by the earth pressing into your back, in precisely the same way you would be accelerated by the floor of a rocket firing steadily through deep space. You cannot feel the difference, and there is no difference to feel, because gravity and acceleration are one and the very same thing. The earth is the floor of your rocket, and it is firing into you, gently and endlessly, holding you off the falling path, and that constant firing is the entire sensation you have always called lying still. The only beings in this whole quiet scene who are truly, restfully motionless, in the deepest sense that the universe allows, are the things in free fall. The dropped stone, halfway to the ground. The astronaut, drifting weightless in her station. The Earth itself, coasting silently around the sun. They are the ones at peace. And you, pressed into your mattress, feeling so perfectly and completely still, are the one being pushed. And there is a place where you can see the truth laid completely bare, where the floor is finally removed and the falling is allowed to proceed, and that place is in orbit, high above the Earth. There is a widespread belief, an almost universal one, that astronauts float in space because there is no gravity up there. This belief is completely wrong. Not slightly wrong, fundamentally wrong. There is a great deal of gravity where the astronauts orbit. The International Space Station circles the Earth at an altitude of only about 250 miles, which sounds high, but is in truth barely a skim above the surface of a world that is nearly 8,000 miles across. At that altitude, the Earth's gravity is still roughly 90% as strong as it is down here on the surface, where you are lying now. The astronauts have not escaped gravity in the slightest. Gravity is pulling on them almost exactly as hard as it pulls on you. So why do they float? Why do we see them drifting weightlessly through their station, tumbling slowly, watching droplets of water hang in the air like tiny trembling planets? They float for precisely one reason, and it is the reason that ties this entire journey together. They float because they are falling. The space station and every astronaut inside it is in a state of continuous free fall around the Earth. It is Newton's cannonball made real, fired around the world at the tremendous speed of roughly 17,000 miles per hour, falling toward the Earth forever and forever missing, exactly as the moon does, exactly as the Earth itself does around the sun. The station is falling, the astronauts inside it are falling, and because they are all falling together, at the same rate, with nothing pushing up against them, there is no ground to stop them, no floor to shove into their feet, and so they feel no weight at all. They are not beyond gravity. They are simply, finally allowed to follow their natural falling path, and a falling body feels nothing. There is something deeply important hidden inside the fact that the astronauts and their station all fall together at exactly the same rate, and it reaches all the way back to Galileo dropping his weights in Pisa. Remember what Galileo discovered. All objects fall at exactly the same rate, regardless of their mass, as long as nothing like air is in the way to slow the lighter ones down. A feather and a cannonball, released together in a perfect vacuum, fall side by side and strike the ground at precisely the same instant. This is exactly why everyone aboard the space station floats together so perfectly. The astronaut, the station, the camera drifting beside them, the trembling droplet of water hanging in the air, all of them are falling at the very same rate, because gravity accelerates every object identically, no matter what it is. Nothing falls faster than anything else, and so, falling together at the same pace, they have no motion relative to one another, and they simply float, side by side, in one shared and silent fall. This idea that everything falls at the same rate was tested in one of the most beautiful demonstrations ever performed, and it was performed not on the Earth, but on the surface of the Moon. In the year 1971, an astronaut named David Scott stood upon the grey and airless plain of the Moon, where there is no atmosphere at all, no air whatsoever to slow anything down. In one hand he held a heavy geologic hammer, in the other he held a light falcon feather, and before a watching camera he let them both go at the very same moment. On the Earth the feather would have drifted slowly down long after the hammer had landed, caught and held back by the air. But on the Moon, in that perfect airless silence, the heavy hammer and the delicate feather fell together, side by side, and struck the lunar dust at exactly the same instant. 3.5 centuries after Galileo first reasoned it out, a man standing on another world had shown it to be true for all of humanity to see. Gravity does not care in the slightest what an object is made of, or how heavy it is. It carries everything along the same falling path, at the same rate, always. You can even taste this strange weightlessness for yourself, without ever leaving the Earth at all, and people do. There are special aircraft that fly in great rising and falling arcs through the sky, climbing steeply upward and then tipping over the top and falling along a precise and gentle curving path. For roughly half a minute at a time, as the aircraft falls along that arc, everyone inside it falls along with it, at exactly the same rate, and so everyone floats, untethered, weightless, drifting freely through the cabin, exactly as the astronauts do, exactly as the Earth itself does around the Sun. The plane has not escaped gravity in the slightest. It is simply falling, and everyone inside is falling with it, and for those 30 silent seconds, the floor stops pushing up, and the weight melts away, and the truth of free fall becomes something you can feel in your own body. It is, in a sense, a way to briefly touch what the whole Earth feels in every moment of its existence. Consider what this means. If you could somehow remove the floor beneath you tonight, if the entire Earth could be made to vanish from under your body for just a moment, you would not feel yourself begin to fall. You would feel, instead, the sudden and total disappearance of your own weight, the pressing sensation in your back, the heaviness of your limbs. All of it would melt away in an instant, and you would float in perfect weightlessness, drifting freely, until the ground you fell toward eventually rose up to meet you. The terror of falling is not really the falling at all. The falling is weightless and silent and strange. The terror is only the certainty of the floor that waits at the end of it. But here is the deepest turn of all, the one that brings us back to the Earth itself. You have a floor. You have always had a floor. Every moment of your entire life, the surface of the Earth has been there beneath you, pushing up into the soles of your feet at exactly the rate gravity tries to send you falling, catching you, holding you, stopping you, so completely and so constantly that you came to believe the holding was simply the natural order of things. You have never once truly fallen in your whole life, not because the universe gently cradles you, but because the Earth has always relentlessly been in the way. The Earth has no such floor. There is no surface beneath the world. There is no ground under the planet to do for the Earth what the Earth does for you. There is nothing out there in the dark to push up against the bottom of the world and stop it from following its falling path. And so the Earth does the one single thing that you have spent your entire life being protected from. It falls. It falls freely, with nothing in its way, exactly as the man falling from the roof falls, exactly as the astronauts in their station fall, exactly as the moon falls. And because it falls freely, with no floor anywhere beneath it, the Earth feels no weight at all. The planet beneath you, the great heavy world of stone and iron and ocean, is in a state of perfect and perpetual weightlessness, drifting through the curved space near the sun, feeling nothing, pressing on nothing, resting on nothing. The only reason you feel heavy tonight is that you are riding on the one part of the earth that is being stopped. The thin crust of solid ground that catches you. The earth itself stops for nothing. The earth is in free fall, and it always has been, and it feels as weightless as a single drop of water hanging in the air of a falling spacecraft, 250 miles above your head. This is the strange and quiet truth that none of the ancient thinkers could have imagined. The truth that even Newton only half saw. The reason it seems as though something must hold the earth up is that, in our everyday lives, something always holds us up. We have never experienced what it is to fall freely with no floor at the end. We project our own experience onto the world, and we assume the earth, like us, must be resting on something solid, must be held against some fall, because we have never once in our lives been allowed to simply fall. But the earth is not like us. The earth has no floor, and needs none, and rests on nothing, and falls forever, and in all that falling it feels no weight, no strain, no danger, nothing at all. It is the most natural state in the universe, far more natural than the strange and constant stopping that we mistake for rest. To be held still against gravity, the way you are being held still tonight, is the rare and effortful condition. To fall freely, the way the earth does, is simply what nearly everything in the cosmos quietly does, all the time, without any support, and without ever once arriving anywhere at all. Now we can finally take apart the very last hidden piece of the broken question. The one piece that even Newton and Einstein left quietly standing. The piece buried so deep in the words themselves that it slips past almost everyone who ever asks. It is the smallest word in the entire question. It is the word up. When we ask what is holding the earth up, we are assuming, without ever noticing the assumption, that there exists a direction called up and a direction called down, and that the earth would fall downward if nothing held it upward. The whole question is built on the idea of a universal down, a single direction that all falling shares, a great cosmic floor somewhere far below toward which everything heavy would eventually descend. But here is the truth that takes apart the question completely. There is no up. There is no down. Not in any universal sense. These directions do not exist anywhere out in the wider cosmos at all. Think carefully about what down actually means to you. Down, for you, simply means toward the center of the earth. When you drop a stone and it falls down, it is falling toward the center of the planet you happen to be standing on. Your sense of down is created entirely by the nearest large mass, by the earth beneath you, curving the space and time around itself, and tipping your natural path toward its center. Down is not a property of the universe. Down is a local fact, manufactured fresh by whatever happens to be the biggest thing near you. For a person standing in a different place on the earth, on the opposite side of the globe from you, down points in the completely opposite direction through space. Their down and your down are not the same direction at all. They point away from each other, toward a shared center between you. And for an astronaut drifting far from any planet, there is no down whatsoever. There is no direction that feels like the bottom. There is only the empty dark, stretching equally in every direction, with no floor, no ceiling, and no preferred way to fall. This is the final dissolving of the ancient question. The earth is not being held up against some universal down, because there is no universal down for it to fall toward. The whole frame, the whole picture of a world sitting above some great cosmic floor, simply evaporates the moment you understand that down is only ever a local invention of nearby mass. The earth does not need to be held up, because there is no up to hold it against, and there is no down for it to fall into. There is only the gentle curving of space around the sun, and the earth coasting forever along its straightest path through that curve. But if the earth is falling around the sun, and the sun does not move, then at least the sun would be something fixed, some still and steady anchor at the bottom of it all. Except the sun is not fixed either. Nothing is. And here the scale of the falling begins to open up beneath us, layer upon layer, until the mind simply lets go and drifts. The earth falls around the sun, sweeping along its great orbit at roughly 67,000 miles per hour, covering 19 miles in every second, falling toward the sun and missing, falling and missing, tracing one full loop each year. But the sun is not the still center of anything. The sun is itself falling, racing along its own enormous orbit around the center of our galaxy, the Milky Way, carrying the Earth and all the other planets along with it. And the speed of that fall makes the Earth's orbital speed look almost gentle. The sun is moving around the heart of the galaxy at more than 500,000 miles per hour. At that staggering pace, you might think the sun would complete its orbit quickly. It does not. The galaxy is so unimaginably vast that even at 500,000 miles per hour, a single trip around the center takes the sun somewhere between 200 and 250 million years. We sometimes call that span a galactic year. And here is a comparison to hold gently in your mind. The last time the sun was in the position it occupies tonight, completing its previous lap around the galaxy, the dinosaurs had not yet appeared on the Earth. The sun has made the journey only about 20 times in its entire existence. You are riding, right now, on a world that is falling around a star that is itself falling around a galaxy. On a journey so long that an entire age of giant reptiles can rise and rule and vanish in a fraction of a single lap. And the galaxy is not fixed either. The Milky Way is falling too, drifting through a small cluster of nearby galaxies that we call the local group, drawn by gravity toward its largest neighbors. The great spiral galaxy Andromeda, the nearest large galaxy to our own, is falling toward us at this very moment, and we are falling toward it, the two of us drawn together across millions of light years of empty space, destined to meet and merge into a single greater galaxy in roughly 4 billion years from now. And the entire local group, our galaxy and Andromeda and dozens of smaller companions, is itself falling, drawn toward an immense and distant concentration of mass that astronomers have named the Great Attractor, a gravitational pull so vast that it tugs whole clusters of galaxies toward it across hundreds of millions of light years. And beyond even that, there are larger flows still, rivers of galaxies streaming toward even greater concentrations of matter, falling and falling through the dark on scales the human mind was never built to hold. Consider what this means for the simple word still. There is, in all of this, no fixed point anywhere. There is no anchor, no pillar, no stationary ground at any level of the cosmos. The Earth falls around the sun falls around the galaxy falls toward Andromeda and the Great Attractor. The whole local family of galaxies streams through the universe towards something larger yet. At no scale, in no direction, is there anything truly at rest for the Earth to be supported upon. The question of what holds the Earth up assumed a stationary universe with a fixed floor. But the universe is not stationary. It is a vast and silent cascade of falling, nested inside falling, all the way out as far as we can see. There is in fact one thing that comes closest to a state of rest, and it is worth knowing about, because of how gently it disappoints the hope for a cosmic anchor. Spread throughout all of space is the faint afterglow of the birth of the universe itself, a whisper of ancient light left over from when the cosmos was very young and very hot. We call it the cosmic microwave background, and it fills the entire sky in every direction, the oldest light that exists. Because this ancient glow is spread so evenly across all of space, it offers something like a universal frame of reference, a way to ask whether you are moving or at rest relative to the universe as a whole. And when we measure our own motion against it, we find that our solar system is moving through that ancient light at roughly 830,000 miles per hour. Even against the oldest and most evenly spread thing in all of creation, we are not at rest. We are racing. And that ancient light is not a floor either. It is not a surface. It is just an average of everything's motion, a faint and useful reference, not a solid ground anyone could ever stand upon. There is no still place. There is no floor. There is, anywhere in the entire universe, at any scale you choose, nothing at all to rest upon. And there is a final, subtle twist to all of this motion. one that Galileo himself first understood, and it deepens the strangeness in a gentle and surprising way. If everything is falling and moving and racing through space at these tremendous speeds, then why do we feel none of it? Why does the Earth's headlong rush around the Sun at 19 miles in every single second not press us back into our beds, or send the oceans sloshing over the continents? Galileo answered this more than 400 years ago with one beautiful thought. Imagine yourself, he said, in the windowless cabin of a great ship, sailing smoothly across a perfectly calm sea. Inside that cabin, if the ship moves with complete steadiness, you cannot tell that you are moving at all. A drop of water falls straight down into a bowl. A ball thrown across the room flies just as it would on dry land. Everything behaves exactly as it would if the ship were sitting motionless in the harbour. There is no experiment you could possibly perform, sealed inside that smoothly moving cabin, that would reveal your motion to you. Steady motion, it turns out, feels precisely and perfectly like rest. This is why we feel nothing as the Earth races around the Sun. The Earth is not speeding up or slowing down in any way that our bodies could ever detect. It is simply coasting, smoothly and steadily, along its great falling curve, carrying us and the air and the oceans all along with it at exactly the same speed. And because we are all moving together, perfectly in step, the motion becomes completely invisible. It feels, from inside, exactly like stillness. The terrifying speed and the perfect calm are not in conflict at all. They are the very same thing, simply seen from inside the ship. And this reveals something even deeper still. There is no experiment that can tell you whether you are truly moving or truly at rest, because there is no such thing as being truly at rest. All motion is relative. You can only ever move with respect to something else. The Earth moves relative to the Sun moves relative to the galaxy. But there is no fixed and final stage, no absolute floor of space, against which any of it could be called the one real and true motion. Every single speed we have named tonight is a speed measured relative to something else, and nowhere in all the universe is there a something that holds perfectly still. So picture, if you can, the full and final shape of it, not a world resting on a floor, not a stack of patient supports descending into the dark, but a vast and delicate web of motion, stretching out in every direction farther than the mind can ever follow. The greatest galaxies are not scattered randomly through space. They are strung together in immense glowing filaments and sheets, with vast and silent empty voids opening between them. A structure that astronomers call the cosmic web, the largest single pattern that exists anywhere in all of nature. And every strand of that web, every galaxy and every filament, is in motion, drifting and falling along the gentle curves that all the mass around it carves into space and time. It is the grandest dance there is, and it has no choreographer, and no stage, and no floor beneath it. There is only mass, bending space, and everything else following the curves, falling endlessly toward one another and around one another, across distances and spans of time that the human imagination simply was never built to hold. And you are inside it, not watching it safely from some stationary place outside, but woven into the very fabric of the falling, riding upon one small bright world, in one quiet strand of the cosmic web, falling along with all of it, tonight, in the dark. The very same motion that carries the most distant galaxy across the void is the motion that carries your bed gently around the Sun. There is no edge to step outside of. There is no still ground to stand upon and watch from. There is only the falling, everywhere, all at once, with you somewhere inside it, small and warm and turning. So let us return, one last time, to that old joke about the turtles all the way down. The ancients feared an infinite stack of supports, each one needing another beneath it, descending forever without ever reaching solid ground. And it turns out the truth is stranger than the joke, and far gentler. There are no turtles, and there is no down, and there is no floor for any stack to ever rest upon. The endless regress that so troubled the old thinkers does not stretch downward into infinity after all. It simply never begins, because the very first step of it, the very first assumption that the Earth must rest on something in some downward direction, was never true to start with. You cannot have turtles all the way down when there is no down for them to descend into. The whole imagined tower of supports dissolves into the open dark, and what remains is only this: a world falling freely around a star that is falling freely around a galaxy that is falling freely through a universe with no bottom, no edge, and no floor that anyone has ever found. And here is the quiet comfort hidden inside all of that immensity, the comfort that begins to soften the vertigo of it. A fall needs a bottom in order to be dangerous. The terror of falling, as we have already seen, is never the falling itself, which is weightless and silent and strange. The terror is always the floor that waits at the end. But the Earth's fall has no floor. There is no bottom of the universe for it to crash into, no surface anywhere in any direction for it to strike. And a fall with no bottom is not a plunge at all. A fall that never arrives anywhere, that simply continues, gently and endlessly, curving through the shape of space, is not a catastrophe waiting to happen. It is an orbit. It is a circle. It is, in the deepest sense, the safest motion there is, because it is forever in the act of falling and forever failing to land, and so it can never ever crash. The Earth has been falling for 4.5 billion years and has never once hit the ground, for the simple and beautiful reason that in all the vast dark depths of the cosmos, there is no ground there for it to hit. If the Earth has been falling for 4.5 billion years and has never once crashed, a quieter and more patient question begins to surface from the dark. Will it ever stop? Is the fall truly eternal, or is it only very, very long? Does the endless missing go on forever, or is there, somewhere far down the corridors of deep time, a final lap, a last circle, an ending to the orbit? To answer this, we have to understand why the falling is so stable in the first place, why the Earth does not slowly drift inward toward the fire, or gradually spiral away into the cold, but instead traces the same patient loop, year after year after year, with such astonishing faithfulness. The reason the orbit is so stable comes down to a deep principle of physics called the conservation of angular momentum. It is a difficult name for a fairly intuitive idea. When something is spinning, or circling, or moving sideways around a central point, that sideways motion is preserved. It does not simply fade away on its own. You have felt this principle yourself. When a spinning figure skater pulls their arms in close to their body, they spin faster, because the spinning motion is conserved and gathered inward. The Earth's sideways motion around the Sun, the very motion that makes it miss the Sun forever, is conserved in exactly this way. It does not weaken, it does not run down, and crucially, there is nothing out in the emptiness of space to slow it down. On the Earth, every motion eventually stops, because there is air to push against, and ground to rub against. Friction everywhere, quietly stealing the energy of motion and turning it into heat. A ball rolled across a floor always comes to rest. But space is very nearly a perfect vacuum. There is no air out there between the Earth and the Sun, no surface, almost nothing at all to rub against. And so the Earth's sideways speed is preserved with extraordinary perfection, lap after lap, with almost nothing to bleed it away. The missing continues because the speed continues, and the speed continues because there is nothing out there to stop it. But where did that sideways speed first come from? If the Earth has been coasting along its orbit for 4.5 billion years, then something must have set it moving in the very beginning, must have given it that original sideways push that has kept it forever missing the Sun ever since. And the answer takes us all the way back to the birth of the Sun and its planets, to a time before the Earth existed at all. Roughly 4.5 billion years ago, there was no Sun and no Earth, only a vast and slowly turning cloud of gas and dust, drifting in the darkness between the stars. The cloud was enormous, far larger than the entire solar system is today, and it was turning ever so slowly, as such clouds always do. Then, perhaps disturbed by the shockwave of a nearby exploding star, the cloud began to collapse inward under its own gravity, all of that gas and dust falling steadily toward its own center. And here that deep principle returns once more, the conservation of angular momentum, the very same principle that keeps the Earth in its orbit today. As the great cloud collapsed and shrank, its slow turning had to speed up, exactly as a spinning skater speeds up when they draw their arms inward toward their body. The vast, slow rotation of the original cloud, gathered now into a far smaller space, became a faster and faster spin. The collapsing cloud flattened out into a great spinning disk, with the young sun forming and igniting at its blazing center, and the leftover gas and dust swirling around it in a turning sheet. And it was from that spinning disk that the planets slowly grew. Tiny grains of dust collided and stuck together, building gradually into pebbles, and then into boulders, and then into great bodies the size of mountains, and at last the size of worlds, all of them sweeping around the young sun in the same direction, carried along by the rotation of the disk they had been born from. The Earth itself condensed out of that turning disk, and it inherited the disk's motion as its birthright. The sideways speed that the Earth carries today, the very speed that makes it forever miss the sun, is not something that was added on later. It is the ancient spin of that original cloud, preserved across 4.5 billion years, handed quietly down from the turning of the gas and dust that gave the Earth its very substance. The Earth has been falling around the sun in the same direction ever since the moment it first formed, because it was born already in motion, born from a spinning disk, born into the fall. This is why all the planets orbit the sun in the same direction, and why they all travel in very nearly the same flat plane, as though laid out upon one enormous turning record. They are all the children of the same spinning disk, all carrying the same inherited motion, all falling around the same star in the same ancient direction it first set them turning. When you look out at the orderly solar system, with its planets wheeling around the sun like a vast and silent clockwork, you are looking at the frozen memory of a cloud that collapsed and spun up 4.5 billion years ago. The order was not designed by anyone. It was inherited, conserved, and passed down through the deep ages from a single slow turning in the dark. So the Earth's endless fall did not begin with a push from any hand. It began with the gentle and inevitable spin of a collapsing cloud, and it has simply continued, faithfully and without a single interruption ever since, because in the emptiness of space there has been nothing at all to slow it down. The sideways speed that keeps you safe tonight, that keeps the whole Earth forever missing the fire at the center, is older than the Earth itself. You are riding, in the deepest sense, on the preserved momentum of the very cloud that made the world. Almost nothing. There is one tiny leak, one faint and almost unimaginably gentle drain on the Earth's eternal motion, and it was predicted by Einstein himself in the year 1916, just 1 year after he completed his theory of gravity. Einstein realized that when masses move and accelerate, when they circle one another or collide, they send out ripples in the very fabric of space and time itself, faint waves that spread outward across the cosmos at the speed of light, carrying away a trickle of energy as they go. He called them gravitational waves. They are, quite literally, ripples in the shape of space, tiny stretchings and squeezings of distance itself, rolling out across the universe like ripples spreading across the surface of a pond. And Einstein was almost certain that they were far too faint for any human instrument to ever detect. He thought they would forever remain a beautiful prediction on paper, real but invisible, too delicate ever to be caught. For a full century he was right. No one could find them. The effect was simply too small, too gentle, too far below the threshold of any machine humanity could build. And then, on the 14th of September in the year 2015, after decades of patient work and the construction of some of the most sensitive instruments ever made, A pair of enormous detectors in the United States, known together as LIGO, felt a wave pass through the Earth. The wave had been created by an event of almost incomprehensible violence, the collision of two black holes, each of them tens of times more massive than our entire Sun, spiraling into one another and merging into a single greater black hole. But the collision had not happened nearby, and it had not happened recently. It had taken place roughly 1.3 billion light years away, which means the ripple had been traveling across the universe at the speed of light for more than 1 billion years before it finally washed over the Earth and through the waiting detectors. And when it arrived, the most violent event imaginable, the merger of two black holes, had been smoothed by all that distance and all that time into a stretching of the detectors smaller than the width of a single proton, a distance so tiny it almost defies belief. The discovery was announced to the world in February of the year 2016, very nearly exactly 100 years after Einstein first imagined the waves. A century after he predicted them, and long after he had died, the ripples in space and time were finally, undeniably real. And here is what this means for the Earth and its endless fall. The Earth and the Sun, circling one another, also create gravitational waves. As the Earth sweeps along its orbit, it sends out the faintest possible ripples in the fabric of space, carrying away a trickle of the orbit's energy. But the trickle is almost nothing. The entire Earth and Sun system, with all of the Earth's enormous mass moving at 67,000 miles per hour, radiates gravitational waves with a power of only about 200 watts. 200 watts. That is roughly the power of a few ordinary light bulbs, drained away from a system that weighs a number of tons with more than 20 digits in it. The orbit is losing energy so slowly through these faint ripples that the rate is almost meaningless. And as the orbit very, very gradually loses that tiny trickle of energy, the Earth does, in principle, creep just barely closer to the Sun, spiraling inward at a pace so unimaginably slow that the number defies the imagination. To actually spiral into the Sun by this process alone would take a span of time with more than 20 digits in it, a number of years so vast that the entire 14 billion year age of the universe, the whole of cosmic history from the beginning until now, would amount to no more than a single drawn breath in comparison. On any scale a living thing could possibly grasp, the fall is, for all purposes, eternal. And in truth, it will never happen at all, because the Sun will die long, long before those faint ripples could ever matter. In roughly 5 billion years from now, the Sun will exhaust the hydrogen fuel at its core and begin to change. It will swell outward, slowly and enormously, into a vast red giant, growing until it engulfs the innermost planets and perhaps the Earth itself, before finally shedding its outer layers and collapsing into a small, dense, slowly cooling ember called a white dwarf. The Earth's fall around the Sun will end, but it will not end with a crash, and it will not end with the slow spiral of gravitational waves. It will end because the thing the Earth has been falling around for all those billions of years will quietly cease to exist in its present form. The fall will end not by arriving, but by the disappearance of the very star at its center. But that ending lies 5 billion years away, and tonight is tonight, and the fall goes on. So let us pause, here near the end of our journey, and try to feel the true weight of the time involved, because it is in that immensity of time that the deepest comfort lives. The Earth has now fallen around the Sun roughly 4.5 billion times, 4.5 billion complete laps, each one a full year, each one a single silent circle traced through the curved space near a star. Try, gently, to hold that number. Every mountain range you have ever seen or imagined has risen up out of the Earth and then slowly worn back down into the sea during this fall. Entire oceans have opened and closed. Whole continents have drifted across the face of the world and crashed into one another and torn apart again, all while the same patient circle was being traced, over and over, around the same warm light. Every creature that has ever lived, every fish and every fern, every dinosaur and every distant ancestor of your own, appeared and lived, and the great majority of them vanished forever. And through all of it, every single moment of it, the Earth simply kept falling, never once arriving, never once crashing, never once stopping to rest. Your own life, your whole life, with everything in it that has ever felt enormous to you, occupies less than a single one of those 4.5 billion laps. You were born partway through one circle, and you will live out your days within it, and the Earth will keep falling long after, exactly as it fell long before. There is a deeper subtlety to this stability, and honesty requires that we name it, that has held the whole family of planets together for billions of years. But on truly immense spans of time, on scales of hundreds of millions and billions of years, the mathematics reveals something humbling. The solar system is, in the deepest technical sense, very slightly chaotic. The tiny gravitational nudges that each planet gives to all the others accumulate so slowly and so intricately that the exact positions of the planets in the far distant future cannot be predicted with perfect certainty. The honest answer, when we ask precisely where in its orbit the Earth will be 5 billion years from now, is that nobody knows, and nobody can ever know, because the very smallest uncertainty today grows, across those vast spans, into a complete and unreadable blur. But notice how gentle even this uncertainty truly is. It does not mean the Earth is in any danger of flying off into the cold or plunging into the fire anytime soon. It means only that the precise details of its path, countless eons from now, are hidden from us behind the sheer and dizzying depth of time itself. The orbit is stable in every single way that could ever matter to a living thing. It is only the far horizon, billions of years away, that fades softly into the unknowable. And there is something almost beautiful in that. The fall is faithful enough to have carried life through 4.5 billion years without a single catastrophe, and yet free enough, at the very edge of deep time, to keep its deepest secrets quietly to itself. So let yourself feel, one last time, the sheer depth of the time across which this faithful fall has carried on. Light from the sun takes about 8 minutes to cross the 93 million miles of empty space and reach the Earth. The sunlight that warms a morning left the surface of the sun 8 minutes before it ever touched your face. And yet that same sun, pouring out that same patient light, has held the Earth in its falling embrace for a span so unimaginably long that the light itself, if it could somehow remember, would have made that 8-minute crossing more times than there are grains of sand on every beach in all the world. Every one of those countless mornings, the Earth was falling. Every one of those countless nights, the Earth was falling. It did not pause for the slow rise of the mountains, or the patient filling of the seas, or the gradual arrival of the very first living things. It has not stopped for a single instant in 4.5 billion years, and it is not stopping now, as you lie here in the dark, listening, drifting, carried along on the oldest and steadiest motion you have ever known. This is the strange and consoling reality of the fall. It is not eternal. Nothing truly is, but it is so close to eternal that the difference cannot be felt by anything that lives, or by anything that has ever lived, or by anything that will live for billions of years to come. The fall has outlasted the mountains. It has outlasted the oceans. It has outlasted every creature that ever opened its eyes to look up at the sky and wonder what holds the world in place. It was falling before there was anyone here to ask the question, and it will go on falling long after the last person has stopped asking it. And tonight, in the quiet and the dark, that same ancient and patient fall is carrying you, exactly as it has carried every living thing that ever was, one more silent and effortless mile around the sun. And so we return, at the very end, to where we began. To you, lying still in the dark, with the gentle weight of your own body pressing down into the bed, and the strange new knowledge that nothing at all is holding it up. We have travelled a long way together to arrive back at this single quiet moment, and the moment has not changed, but perhaps the feeling of it has. We began with what seemed like one of the most basic and answerable questions a person could ask. What is holding the Earth up? And we discovered, layer by layer, that the question itself was the illusion. Nothing is holding the Earth up. Nothing ever has. There is no floor, no support, no anchor, no pillar, no cosmic ground of any kind. The Earth is falling, and it has always been falling, freely and weightlessly, through a universe that has no bottom for it to land upon, and no up against which it could be held. Perhaps that is a frightening thought. Perhaps, lying here in the dark, the idea of a world resting on nothing, falling endlessly through an immensity with no floor and no anchor, and no solid certain ground anywhere, is one of the loneliest things a mind can hold. There is a kind of vertigo in it, an old animal unease, the sense that the bottom has dropped out of everything we trusted, that the solid world we have always stood upon was never solid at all. Perhaps the absence of any support beneath the world feels, in this moment, like the absence of safety itself. Or perhaps it is the exact opposite. Perhaps the lack of a floor is the very thing that keeps you alive. Consider it gently. A world that was truly held still in space, fixed and motionless beside the sun, would not be safe at all. It would simply fall straight into the fire, in a matter of weeks, with nothing to carry it sideways, and nothing to make it miss. It is only because the Earth is falling, only because it is in this endless, supportless, weightless free fall, that it traces its safe and steady circle at just the right distance from the sun, close enough for warmth and light, far enough to keep from burning. The fall is not the danger, the fall is the safety. The very thing that has no floor beneath it is the very thing that holds the seasons in place, that keeps the oceans liquid, that keeps the air at the temperature of life, that has made it possible for there to be a you at all, lying here, warm, breathing, alive, wondering about any of this. Everything you have ever loved exists because the Earth is falling, and never lands, and never stops. These are not questions that physics can answer for you. Physics can tell you, with perfect precision, that the Earth rests on nothing, and falls forever and feels no weight. It cannot tell you how to feel about that, whether to lie here in the dark feeling small and untethered in a universe with no ground beneath it, or to feel quietly held and strangely at home in a cosmos that never needed any ground to begin with, is a choice that each of us makes alone, somewhere in the silence, usually somewhere very close to sleep. Different people will feel it differently, and both feelings are true, and you are allowed to drift between them as gently as the Earth drifts around the sun. And here, at the last, let us pull back as far as it is possible to pull back. One final widening of the view. You exist on a single small falling world, circling one ordinary star. That star is one of several 100 billion stars in a single galaxy, the Milky Way, itself falling through the dark. And that galaxy is only one of perhaps 2 trillion galaxies scattered across a universe that stretches at least 93 billion light-years from one side to the other, a distance so vast that light itself, the fastest thing there is, could never hope to cross it in the entire age of the cosmos. Nothing in all of that immensity is being held up. None of it rests upon anything. Every star, every world, every galaxy, every river of galaxies streaming through the deep, all of it is falling, turning, drifting, orbiting, in one vast and silent dance, with no floor beneath it, and no ceiling above it, and no edge anywhere that anyone has ever found. You are a small warm point of awareness, riding on a falling speck, in an unimaginably enormous cathedral of falling things, and the whole of it has been falling, beautifully and without support, since the very beginning of time. It should make you feel tiny, and it does. But notice that the smallness is not the whole of the feeling, because within all that supportless, falling immensity, here you are, warm, breathing, falling exactly as you are meant to fall, on the one world out of all the countless worlds that you know holds life, beneath the one sky you have ever called your own. The universe is vast and cold and indifferent, and it never once promised the Earth a floor to rest upon. But in all that vastness, in all that indifference, it left room. It left room for a falling world to find its gentle circle around a star. It left room for oceans, and for air, and for warmth, and for the slow miracle of living things. It left room for you, lying here in the quiet, held by nothing, resting on nothing, and yet perfectly, completely safe. The fall does not threaten you. The fall is the reason there is anything here to threaten at all. So as your breathing slows, and the dark grows soft, and the day finally lets go of you, you can let go too, just a little, of the old idea that you need to be held up by something solid in order to be safe. You never did. The Earth never did. For 4.5 billion years it has rested on nothing whatsoever, and never once has it fallen anywhere but exactly